Hey guys, welcome back. Welcome to Vedantu's JEE channel, everyone. How are you all? I hope all of you are doing fine, and I especially welcome the JEE 2021 aspirants on this channel right now. So, guys, as you can see it on the screen, the session that I have come up with is the recap session for physics for the 2021 aspirants. Now, what does it mean? Does it mean that we are going to revise everything which is related to 2021? No, it's not a revision session, it's more of a recap session, especially for students who have missed a few sessions which already we have completed since the beginning of this academic year. We started our session in the month of March, we started, right? So since then, we have completed two chapters, electrostatics and current electricity. What have we completed in all these chapters, the sub chapters of that? That is what this session is all about. It's a quick recap of the topics which we have completed for JEE 2021. Okay, so I'll tell you towards the end of the session how can you uh, cover up by watching those sessions as well. Okay, so let's start the session here. Before we go forward, let me start off with my introduction. So, guys, if you do not know me, this is me, your Suri Sir. I'm an alumnus of IIT Bombay, and on this channel, I'm known as Mogambo. Why am I called Mogambo, guys? Is because when you will crack this examination of JEE, Mogambo Khush hoga. Okay, and if you are new on the channel and would want to continue from here and want to be regular on this channel to complete your preparation for 2021 JEE examination, then guys, this is the daily schedule that we follow on this channel. Every day at 9 o'clock, we meet for theory discussion. You can see that on Monday and Thursday, you meet Harsh sir for chemistry theory. Every Wednesday and Saturday, you meet me at 9 o'clock for theory sessions of physics. And every Tuesday and Friday, you guys will meet Arvind sir for mathematics sessions for the theory classes. Okay. But if I speak about Wednesday, in fact, Monday, Wednesday, and Thursday, we meet at 8 o'clock also, and that too specifically for MCQ discussion. Okay, so guys, I want you people to keep this time slot in your mind if you are new, that 9 o'clock definitely you have to be on the channel, and on Monday, Wednesday, and Thursday, you should be here for MCQ discussion. Okay, and if you are new, then I would also want you people to subscribe to the channel right now. Also, press the bell icon so that whenever any of us come live, you get the notification. Okay, people. So let's start the recap for JEE 2021. So guys, as I said, so far we have covered two chapters. One is electrostatics, the other one is current electricity. Let's start with the recap of electrostatics. So in electrostatics, these are the subtopics that we cover: Coulomb's law, electric field, electric potential, electric dipole, Gauss's law, earthing of conductors, capacitors, series and parallel combination of capacitors, force between the plates of a capacitor and the energy which is stored in the capacitor, and the capacitors with dielectric. So what do we study in Coulomb's law? This is the very basic law that I'm sure all of you must be aware about. Okay, this is the most fundamental law that sets the basis of entire electrostatics chapter, which you know that whenever there are two charges which are placed in a close vicinity of each other, they will either attract or repel depending upon their polarity. This is the magnitude of that force, which is k q1 q2 by r square. Keep this formula always in your mind. It is very much similar to the formula for gravitation. Okay, guys. In this, if you see, k is represented as 1 upon 4 pi epsilon naught, where epsilon naught is called as the permittivity of free space. And what does permittivity in general mean? Permittivity is going to be the measurer of the permission which is given by the medium for two charges to interact. Okay, and as the medium will change, the value of k will also change accordingly. Okay, and when we are going to use any other medium than vacuum, then we'll require the value of dielectric constant or the relative permittivity of that medium. Okay, so after Coulomb's law, we moved towards the discussion of electric field, which was defined as the force acting per unit charge, which also tells you about the strength of a given charge, means how much it will influence any neighboring charge. Okay, so when we speak about a point charge here, you can see that the expression is kq by r square. Okay, and when we want to talk about bodies which are not uh, point charges, then we have to move towards the process of integration like this. Okay, what we did here, we divided a body into multiple charged small particles, and we found the electric field because of individual charges, and then integrated over the surface, over the volume, over the length of that particular body. Okay guys, so accordingly we found the electric field because of a linear object, two-dimensional object, or a three-dimensional object. What were the objects that we talked about? We talked about a straight linear infinitely long charged body for which the electric field came out to be 2k lambda by r. Similarly, we found the electric field on the axis of a ring. At the center, obviously the value will come out to be 0. And more importantly, we talked about the spherical bodies. For any spherical body, remember that the sphere, if it is conducting, then the expression of electric field outside, surface and inside will remain same whether it is a hollow body or a solid body. Okay, the expression is kq by r square outside the sphere, kq by capital R square on the surface, and 0 inside. And when we were dealing with a non-conducting sphere, then in that case, if we were dealing with a solid sphere, then inside the sphere also there was some electric field which came out to be directly proportional to the location of the point. Okay. Also, we talked about the properties of the electric field. Very important are these properties. Please go through those properties as well. Okay. After electric field, we moved towards the discussion of electric potential, very similar to the discussion that you might have had in 11th standard for the gravitation chapter. Electric potential, as you all know, is defined as the work done per unit charge in bringing a unit charge from infinite distance to a given point under the influence of an electric field of a given charge. Okay, so if you look at this particular diagram here, this capital Q charge is creating its own influence of electric field, and we want to bring a unit charge. Unit charge means 1 coulomb charge from infinity to a given point P, and for that we will require the process of integration at times when especially the electric field is variable, and for a point charge that expression comes out to be kq by r. Okay, this helps us talk about something called as equipotential surface. Okay, when we have a body around which there are multiple points which have the same potential value, so if I construct an imaginary surface which contains all those points which have the same potential, then the imaginary surface formed by this is what we call as the electrostatic equipotential surfaces. And important part about equipotential surfaces is that whenever we are going to make a charged body move on any equipotential surface, then the electric field will always be perpendicular to the direction or the surface of that equipotential surface, because of which the electric field, because of this charge, say this is the charge and this spherical surface is the equipotential surface around it. So if I will make a second charge or a unit charge, maybe any charge, move on this spherical surface, then the work done by the electric field of this central charge will come out to be 0, because the electric field will be perpendicular to the direction of the velocity or the displacement. Okay, so what is important to understand is that the reason why we define electric field is more or less the same reason we define electric potential as well. We define electric field because we want to talk about the force which is applied by a charged body on a unit charge, and same is the reason we define potential, because we want to talk about potential energy, and potential energy could be easily found if we know the value of the potential because of a charged body. Like we know the value of electric field of a given body, so whichever charge particle will come in its influence, will just multiply the value of that charge with the electric field value to get the value of the force, which comes out to be QE. Similarly, the value of potential energy stored between two charges, small q and another charge whose potential is V, can be found very simply by multiplying the external charge with the potential of a given charge. Okay guys, after that we extended our discussion towards electric dipole. A dipole is a very uh, systematic arrangement of two small charges, not like, but small charges. Rather, they have equal magnitude and opposite polarity. If one is plus q, the other one is minus q, and they are separated by a relatively very small distance. Okay, so the diagram that you see here shows that the charges are separated by a distance of 2a. This 2a distance we define so that measurement can be done from the center of the dipole, and each charge is at a distance a from the center of the dipole. So we define the strength of the dipole as the dipole moment, and it is calculated as the magnitude of one of the charges with taking its product with the separation between the two charges. That means q into 2a is the value of the dipole moment, and it's a vector quantity, by the way. Its direction, as you can see it in the diagram also, is from negative to positive charge. Now, what is our intent by defining this dipole moment? We want to study how the dipole will behave whenever you will be placing it into an external magnet electric field. Okay, like in the second figure you see that a dipole is being placed in an external electric field, so it will experience equal and opposite force because of the two charges being of opposite polarity. So the net force will be experienced by the dipole will be zero, but the torque experienced by the dipole will not be zero. Rather, the two electrostatic forces acting on the dipole body will try to behave like a couple and will create a torque which is eventually found to be equal to the cross product of dipole moment and electric field. That means P cross E. Also, as the dipole is experiencing a torque, because of that, it will store some potential energy as well, which is found as the dot product of P and E. Okay. Now, this was the basic introductory part of electrostatics. After that, we took our discussion to a very specific topic called as Gauss's Law. Gauss's Law is a very beautiful concept which helps us find out the value of electric field because of different objects. It actually works on the concept of electric flux. I hope you all know what flux is. Flux is basically the number of field lines which are crossing a given area. That's why it is defined as the dot product of electric field and the area vector. So if you have an area through which electric field lines are crossing, then the dot product of electric field and area vector, if it comes out to be uh, E into A, then the angle is 0 degree. If it is coming out to be 0, then the angle is going to be 90 degree. And for any other angle, you will write it as E into A into cos of theta. Okay. Now, how exactly Gauss's law work? Gauss's law works on the basis of the flux, which is generated by a combination of charges which are enclosed in a Gaussian surface. Now, Gaussian surface is a very, beautiful imaginary concept though, and in order to understand and apply Gauss's law, we consider an imaginary 3D envelope inside which there would be some charge which will be enclosed. Now, if we look at the charges, overall, the net value of charge will have some electric field lines either going out or coming in into the Gaussian surface. So, because of that, we write the total flux of the net charge, which is E dot dA, the integration of that, and we say that it is equal to the net charge enclosed in the Gaussian surface divided by the value of epsilon naught. Like in the example that you see here, the total charge is 2q divided by epsilon naught. This value will actually be equal to the net flux, net outgoing flux through this given Gaussian surface. Now, why we are talking about this Gaussian surface and the phenomena of flux linked with it? Because it helps you find out the value of electric field due to different arrangements like this one. In this or in any situation, when we try to consider a Gaussian surface, we take care of two very important things. Say we are interested in finding the electric field at this particular point, so that point must lie on the Gaussian surface that we are considering. This dotted circle that you see is a three-dimensional sphere, and the point on which you are interested in finding electric field must lie on that surface. Secondly, we make sure that the surface shape is such that the electric field and the area vector at that point must be either making an angle of 0 degree or 90 degree or 180 degree in order to find out the value of the electric field. So we apply that and find out the electric field expression because of uniformly charged solid sphere, uniformly charged spherical shell, uniformly charged infinitely long rod, and also the infinitely long plane sheet. We did these derivations as well. Okay. After that, we moved towards the concept of earthing of conductors. Earthing of a conductor is a very interesting and a very practically applicable and useful concept that we talked about. The basic thing that we worked with is considering that any object, if it is connected to earth, yes, if you connect any object, if you bring it in contact with the ground or earth, then the net potential of that body becomes equal to the potential of the earth. Earth being a very, very, very big sphere, its potential cannot be increased by any other charged body present on the earth, as the size of the earth is very big, so its capacity is very, very, very large. So its potential more or less always remains same, and we consider that value always to be equal to 0. So whenever a body comes in contact with earth, the charge flow happens in such a way that the net value of the potential of the body along with the earth becomes 0. Okay. When we speak about the next concept after the earthing, it's a very important concept called as capacitance. A lot of questions come from the concept of capacitors in the examination of JEE as well as in NEET. So capacitor we defined as something which is very much in coherence with the concept of capacity only, and capacitance was understood as the amount of charge which was required by a body to increase its potential by 1 unit. And the eventual concept that we want to talk about are different devices which we call as capacitors, which will store the energy. So eventually capacitors will become an energy storing device. So apart from a battery in a circuit, one of the elements that we get introduced to in an electrical circuit later on, the very first element that we get introduced to is basically a capacitor, and its basic job is to store charges, and by storing charges it will try to store energy. Okay. Then we talked about series and parallel combination in the next session. Uh, Remember that whenever capacitors are connected in series, their net value, the effective value, the value which will replace multiple capacitors by a single capacitor, is found as the reciprocal of the all values of capacitance, and we find it as 1 upon Cs as 1 upon C1 plus 1 upon C2 plus 1 upon C3 and up to the values of capacitance which are available. And if we talk about capacitance in parallel, then it is very simple. The values of capacitance will straightforwardly added. Okay, that means C1 plus C2 plus C3. Okay, guys. Uh, there was a specific type of capacitance which is usually being discussed, and that is what we call as parallel plate capacitor. So capacitor being a device which will have two conducting bodies, one will be positively charged and equal amount of negative charge will be given to the other body. So being two oppositely charged bodies placed in a close vicinity, they definitely try to attract each other. So we found the value of the force experienced by the two plates because of each other, and the amount of energy which is stored inside the capacitor body, which is a very important formula, half CV square or half Q square by C. And also we found the energy density, energy stored per unit volume of a capacitor device. Okay. And finally we talked about the cases where if we have a medium change between the plates of the capacitor, if we replace a vacuum body capacitor with a dielectric medium, then the capacitance value will increase and will result in change in capacitance, voltage, charge, electric field, and possibly the energy as well. Okay. So guys, these were the things that we discussed in electrostatics as a chapter. It went almost for a month long session, marathon it was. Okay. And very recently we completed the second chapter, that is current electricity. What were the topics that we covered in current electricity? These were the things. Okay. These are the topics which we covered here. Let's go to them one by one to have a quick recap. So we talked about how current flows in a conductor. You know the basic understanding that flow of current is nothing but flow of electrons in a given conductor. So whenever electrons will travel in a conductor, they will create some current, but that only becomes possible when you have uh, power source connected across the conductor. That means what? Randomly also when there is a metal body, Metal body has readily available free electrons to travel from one point to another, but current only becomes significant when you have a battery connected to that conductor. Okay, so we talked about how the electrons will be drifted because of the presence of that power source creating an electric field. So that drift velocity expression became very important. Based upon that, we found the value of the current in terms of the drift velocity came out to be NEAVD, where N is the charge density in this particular conductor, E is the charge of the electron, A is the area of cross section of this conductor, Vd is the drift velocity of your electron. Then we defined the current density as well, which turned out to be a vector quantity, and because of that we said that the current is the dot product of current density and area vector. That's why it's a scalar quantity as well. Okay, then we went to a very famous law that you guys studied in 11th 10th standard, in fact, for the first time, which we call as Ohm's law. Okay, it becomes actually the basis of definition and existence of resistance. So from here, we talked about the concept of resistance, how it varies with temperature, and we moved towards the discussion of series and parallel combination of resistance, which I'm sure you all remember. In series, your resistances will simply be added, but in parallel, you will take them in reciprocal, just opposite to what we studied in capacitance. Okay. Then we talked about the power source in a given circuit, how the cell and the or a battery behaves. Okay, we talked about that in case of charging, in case of discharging, what exactly is the concept of terminal potential, what is the difference between terminal potential and EMF of a cell. Okay, then we talked about what happens to the cases when you have multiple cells connected in series or parallel. So what is the net effective voltage applied by the battery, and how much amount of energy or power is supplied by the battery is what we talked about. Okay, and then we went towards the problem solving part, one of the very important concept of this chapter. In fact, I would say this is where the entire soul and essence of the chapter, problem solving wise, lies. These are the Kirchhoffs laws. We talked about two very important laws here: Kirchhoffs current law, also known as junction rule, and Kirchhoffs voltage law, which is also known as loop rule. In short, if I say, current law says that the net value of the algebraic value of the net current coming on a junction is always going to be zero, or you can say that the total current coming into a junction will be equal to the total current going out of a junction. And when we speak about the KVL says that the net value of all the voltages on battery and resistances or any circuit elements, that net value of voltage will always be equal to zero. Based upon that, we solved a lot of questions, and then we moved towards the measuring devices. First device that we actually talked about was galvanometer, but galvanometer had its own limitations, that it can only measure very small currents which are of the order of micro to milliamperes. So we need to convert it into a meter and voltmeter. So if you connect a very small value shunt resistance in parallel to the galvanometer, we converted it into an ammeter. And if we connected a very big value of resistance in series with the galvanometer, the galvanometer got converted to a voltmeter to measure current and voltage respectively. Okay. Then we move towards a very interesting topic called as Wheatstone bridge. You all must have heard about them already. Okay, the Wheatstone bridge concept and the meter bridge concept, you must have heard about them. The balancing Wheatstone bridge is the condition when you have this kind of a circuit and point Q and S over here will have the same potential. So this middle branch where galvanometer is connected will have no current flowing through it. What is that condition? Condition is that ratio of R1 to R2 and ratio of R3 to this Rx, that value should be always equal, and then you will not have any current flowing through Q to S or S to Q. Now same concept becomes the principle of a device called as meter bridge, which is used to find out unknown resistances. So we have this device which we talked in the same lines, that the ratio of these two resistances will be equal to the ratio of resistance of AB to BC, and resistance is directly proportional to the length of a wire. So accordingly that ratio became in direct proportionality with the balancing length. Okay, now the last but the most important part of the measuring devices was potentiometer, which turned out to be a very interesting and a very important device. I would say a very idealistic voltmeter as well, because potentiometer works on a null deflection method and does not consume any energy from the power source which you are connecting it to measure the value of the potential. So the potentiometer had certain applications. We use it to find out the value of the EMF of an unknown battery, find out the internal resistance of an unknown battery, or compare the EMF of the two cells. Okay, so do go through all these applications, and recently we solved a lot of MCQs on the measuring devices as well. Okay, guys, so these are the two chapters that we have completed so far, starting from the month of April till this mid of July. Probably, if you are watching this video relatively later in this year, you might find more chapters being completed on the channels already. Okay, so if you want to know how can you cover up the topics which we have already done, means how to find those lectures videos which we have already completed on this channel, for that all you have to do is go on the playlist of this channel and look for this playlist, which is JEEt Lo 2021. It's a subject wise playlist. You can look for physics as a subject and you'll be able to find each and every session completing all those topics that I was speaking about. Okay. And if you happen to be a 2020 student, that means if you're preparing for JEE 2022, then you can also enroll for the new crash course which we are starting from 20th of July. Okay, and if you are interested in taking your JEE preparation, give it the last round of boost which it requires, you can join it, and the batch is starting very soon on 20th of July. It is starting. Okay, for that, all you have to do, guys, follow this link which is available in the description box. It will direct you to a page where you have to put the coupon code SMCC, and the crash course is actually worth rupees 25,000. You will get it for just, the pricing has actually got even more updated. It is just under 3,000 rupees now. Okay, guys. Also, if you are interested, you can enroll for the test series where we are giving 10 full length tests along with live discussion on the platform and unlimited doubt solving. For that, the link is again available in the description box of this video. And when you will click over there, you will be directed to a page where you need to put the coupon code SM test. And the test series is actually worth rupees almost 10,000 rupees. If you use this coupon code, you will get this test series for just 1399. Okay, guys. And if you are a long-term student, that means 2021 or 2022 students, then you can also come and become a part of Vedantu family by joining the Telegram channel, where we share assignment solutions, study material, and daily updates as well. For that, the link is this, also available in the comment section or the description box. You can click over there and join the Telegram channel of ours as well. Okay, guys. So all my 2021 students, I hope you got the idea of the topics that we have covered already. The recap must have been very helpful for you. If you enjoyed or if you liked the session, if it became helpful for you to get a bird's eye view of what has been completed already, then do hit that like button. Okay, share with your friends and subscribe to the channel if you have not already, and press the bell icon so that whenever your Suri Sir comes live, you get the notification. Okay, guys, with that note, I'll see you regularly on the session. Keep coming as per the schedule that I shared with you all, and let's crack JEE. See you all. Bye bye, guys. Take care.